Let's take a brief look at what's required with north arrows and with scale on your drawing. There are three types of north that you might encounter. There's true north, and that's the north on a globe or on a map. That's the lines of longitude that don't change. There's magnetic north. That's the north your compass needle points to. And magnetic north is changing all the time because inside the Earth is a molten iron core. That's what generates our magnetic field. And that iron core is sloshing around because it's kind of liquidy, plasticky. And so that magnetic north pole is constantly on the move. So we don't usually put that on an architectural plan. And then the third type is plan north. And I'll show you what that refers to. Usually, your building project is not going to be precisely lined up with true north on the map. It'll usually be off just a little bit because that's the way the Earth is. But as a drafter, or an architect or a contractor or whatever, you want to orient your building in some direction, some general direction, so that the contractor knows which side they're facing and what goes on what side. So you're looking for a kind of north that's approximately north, and that approximately north is called plan north. Here's what we mean. This is a campus plan of Lane Community College with the topographic lines and everything. And I've oriented the sheet here so that this is what you would see if you went on a place like Google Maps. You would find that actually the campus is a little bit off from true north. It's about 15 degrees off. But if you're making a drawing, you don't want to tilt your whole campus 15 degrees because that doesn't fit efficiently on your sheet. You want it to be square with your piece of paper. And so here you can see on this slide I'm showing, here's the direction of true north relative to the way that the campus actually sits on the ground. So what the architect or drafter does is they use plan north. So here is the LCC campus plan on a piece of paper with a north arrow at the bottom of the sheet, and that north arrow indicates what you call plan north. That is approximately in the north direction, more north than another direction, but it's not exactly, because here at the very bottom of this slide is the direction that true north actually is. So when you put north on your drawing, usually it's plan north. You'll decide which way to orient your building on your sheet at the beginning, and then once you've decided that orientation, usually it's north at the top of the sheet, but whatever you decide, then you keep that same orientation all the way through every single plan in your set of drawings. And you can, if you pause for a minute and imagine what would happen if you had one plan with north at the top, and then you had another plan where you decided to put north at the bottom. You could wind up with something built backwards, and that would be really expensive. We don't want to do that. So we always keep everything pointed the same direction. And if we possibly can, that direction has north, or rather plan north, at the top. Now there are some buildings where maybe they're long and narrow in such a way that you really have to rotate them so that you have east or west at the top. That occasionally happens, not very often, but you might encounter that. In your north arrow, you can either just have north, which many people do, or you can indicate where is plan north and in relation to true north, and that's what this National CAD Standard arrow is illustrating. Something I wanted to say about that. Oh yes, I wanted to say that the north arrow goes down in the bottom corner of your sheet, sort of in the lower right-hand corner of your title block. Can you think what these bubbles are around this plan view? I hope they are making you think of grid lines, because that's what they are. Okay, now there are all kinds of north arrows out there in the world, and I'm afraid that the National CAD Standard does not have a standard arrow. You can put whatever kind of wacky north arrow you choose on your drawing, and you will see some really baroque, swirly, squiggly things out there. I hope you, well, you may use what arrow you want. If it were me, I would keep my arrow as simple as possible. So here are two kinds of examples. The one at the top here, I believe, is out of the National CAD Standard. Not that you have to do it, it's just an idea. And you'll notice they show north with an extra thick line and the letter N. At the bottom of this slide is another way to do a north arrow. This kind is real common, and this is the kind of north arrow you'll notice I have put on your CAD title block for this class. And on this slide, I'm showing you how you can draw this north arrow. So you start with a circle. You make the circle 5/8 of an inch in diameter. And then at the quarter points of the circle, which are quadrant O-snaps in AutoCAD, you draw the beginnings of the pointy arrow. And then you offset those lines 1/8 of an inch. And then you have another pair of lines going vertically that are 1/8 of an inch apart. So you would go 1/16 of an inch off to either side of the center line. And then you use your trim command and you come back and trim out the circle between those lines. So there's another kind of north arrow. Now, scale, and the scale here means what viewport scale are you using? How much have you scaled down your great big building to fit into your piece of paper? There are two different ways you can tell the reader about the scale. One of them is graphically, and that's this kind of device up here in the top. You also see that kind of device on maps. I think every map has a graphical scale. And the reason for that is because maps are printed at all different scales, and you want the reader to have a good sense of what scale the thing is. You can also express the scale numerically with numbers. So, for example, 1 inch equals a foot. 3/16 equals 1 foot. 1 to 20. 1 to 50. So on and so forth. Those are numerical. The CAD standard says you must give the numeric scale on every drawing. So you must say whatever 1 inch equals 120 feet, that's for a great big site plan, 3/16 of an inch equals 1 foot, or whatever your scale is. You have to write that on your drawing. You can use a graphical scale, but it's optional. So the graphical scale is good if you think your drawing might be reprinted and maybe scaled down. For example, you might have a drawing on a big D size or E size sheet, but out there on the job site somebody's going to print it on a B size printer and scale it way down. In a case like that, you might want to have a graphical scale on here. So I have given you a homemade graphical scale on your title block. It looks like this. You're welcome to delete it if you want to. if you use a graphical scale, you need to make sure that these numbers here on the scale match the scale that your numerical scale is describing. So here, this is my graphical scale for a big site plan that is a scale of 1 inch equals 120 feet. So here these first two bumps are 1 inch long on the piece of paper, and I've put a 120 under that. Well, if you now are going to scale your drawing at, let's say, 1/4 of an inch equals a foot, these numbers are going to be totally different. So it takes some head scratching and maybe calculator punching to figure out what numbers you should put there. Most of the time you'll probably decide, heck with it, that's too hard, I'm just going to erase that thing. But at the least you want the north arrow and the numerical scale.